You are in the session about usability for immersive tech. My name is Jen Murphy. I'm the founder and CEO of Quantum Improvements Consulting. So if that's what you meant to do, you're in the right place. And we'll go ahead and get started. So first of all, who am I? That's me. Like I said, I'm the founder and CEO of a small business in Orlando, Florida. So it's based out of there. We've got people in a variety of locations, though. I'm the one on the West Coast. Our company works a lot in human factors, and that's basically what we're going to be talking about today. A lot of you are probably not familiar with the ideas behind human factors work and human factors research and usability in particular. So I'm going to try and keep it at a pretty low level. We do a lot of work for the federal government and the military, but we also work in the commercial space. Basically, we're learning technology consultants. So what we do is talk to our clients about what their specific training problems are, and they're usually training problems, although they're not always. But we do needs analysis, understanding what the issue is, and then designing and implementing a custom solution for them. So we work across a broad variety of technologies, and the things that I'm going to talk to you about today are applicable to all sorts of technologies, but I know that immersive tech is something that everyone's really interested in these days. So I'm going to focus on VR in particular. But what I'm going to talk to you about can really be applied across all hardware and software solutions, and it really should be. And I'm not going to promise you that you'll be an expert in this at the end of the session, but I am going to give you some resources if you want to do some deeper digging yourself. And we can go ahead and get through that too. My background, I do have a PhD in cognitive and experimental psych from the University of Georgia, the national football champions this year. Go Dogs. That's where I got my degree from. And over the past 17 years, I've been working as a federal civilian, but also as a small business owner in the space of researching learning technology broadly. That's always kind of been my job. So that's who I am. So what are we talking about today? You're rolling out some new immersive tech. You've got a guy here in a VR headset, for example. So how do you know if it actually works? Go Gators, come on. How do you know if it works? So the first question that you have to ask yourself is like, actually, what does it mean to say that something works? And usually in our circles, we talk about training effectiveness or learning effectiveness. And we usually talk about things like Kirkpatrick's 4 levels. A lot of people have a lot of feelings about that model. I've got my own. That's a different talk. But we talk about whether or not somebody learns the thing that they're supposed to learn, or they can do their job better, or they like it better, or the organization is a better place at the end of the day because of the thing that we've implemented. That's usually what we talk about. If you're in corporate management, you might talk about return on investment. So especially when we're talking about learning technology, the question is, does it provide the bang for the buck that that we thought it would when we invested in it? And so you include cost data in that. And those are two very, very important things, and probably like a big part of it. But when we're talking about technology, hardware or software, we need to address another issue, which has to do with usability. Usability is one of those words that it sounds like you probably know what it means, but you might not. So really, when we're talking about usability, we talk about the extent to which your solution is something that what we call the end user, or the learner probably, finds easy and pleasant to use. And the reason that this is important is that if you don't engage well with a solution, then you're not likely to use it. So you might hear a couple words that you're not super familiar with in this talk. And the reason why is that as learning technologists, we're starting to think, we need to think a little bit more in terms of the language of software and hardware development. And we don't usually have to do that, right? Like, we've got out-of-the-box solutions that we can use for all sorts of stuff. But really, when we're implementing something new, we have to think about it from the perspective of someone who's designing this solution from a human computer or human technology interaction perspective. So that's really what usability is the extent to which you can get at something and find it easy and accessible to use. This is one model of thinking about usability as part of the user experience. This is Morville's honeycomb. This is one of several different ways of thinking about user experience. But when you hear the phrase UX, that's really what we're talking about, is all the different ways that we make sure that the solution that you develop or the technology that you're using is valuable in a lot of different ways to the people who are using it. And that's different than saying whether or not something works, right? So software is functional. That doesn't mean that it's great. For a lot of the first end of the pandemic, a lot of us were getting used to a variety of virtual platforms, much like this one. And some of them are more usable than others. And you might have been frustrated in the past with, particularly Microsoft has some usability issues when they first roll out a product, because Microsoft's philosophy is to get something in the hands of users and get feedback quickly. So sometimes things are a little buggy or wonky. I know in my experience, Microsoft tends to broadly change the user experience without warning you, and it like freaks you out. So the question is not whether it's functional. The question is it something that people actually like engaging in? Is it something that some people want to use? So I'm going to give you an example. Okay, what's that? Pretty much everybody here knows that that is a remote control for like your cable TV. So like your direct TV or something like that, that's a remote, right? So if I asked you the question, does this remote work? If the batteries are in it, if it's like, in the vicinity of your television, it probably works, right? Like you can probably get to whatever show you want to using this. The buttons all work. That is one question. However, does the remote work for your grandma is a very different question. So, I don't know how many of you have people in your lives like this, that if they see something with this many buttons, they're just like, oh my God, I don't even know what to do with it. I don't know where to start. I've got like 4 remotes in my apartment, and sometimes I get confused, and there are definitely buttons that I do not use. And if you were to design a solution for somebody who has that kind of need, this really is a better design, because it just highlights the things that you need. And how many people have actually done this for their parents or their grandparents or somebody like that, where you're like, you know what, you don't need to worry about all these buttons, you just need to worry about these. There's a lot of software that you probably use that you ignore about half of the buttons on it too. Now, the reason that this is important to think about is that the extent to which something is usable entirely depends on your audience. So just because something is usable for me doesn't mean it's usable for somebody else. And this gets to the concept of user-centered design. And what we talk about in our industry really is usually learner-centered design. And so you have to understand your end user or your learner extremely well. You need to know where they're coming from. You need to know their background. You need to know what they're trying to do, what they're trying to accomplish, and take that into consideration when you do your usability analysis. Just because, and Microsoft Word is another great example. It's probably one of the most powerful tools that you have on your computer. However, 95% of it you don't need, because you might not be a power user. PowerPoint is the same way. PowerPoint can do all sorts of stuff, but you might not need all of it. And a lot of your learning technology is probably the same way. So the very first step in thinking about design is a real deep understanding of your learners and what it is that they're trying to get out of it and where they're coming from. With virtual reality, this is extremely important, because one of the reasons that VR, in my opinion, hasn't really taken off during the pandemic is that there are a lot of user experience issues with it, and it has to do with who your users are. So we were all promised a couple of years ago that VR was going to be like the next big thing, and everybody's going to be doing everything in VR, and we're all excited about it. The Quest comes out. The Quest is like $300. It's a good price point. They've got games that are not bad. Everyone's playing Beat Saber who has a headset. And you would think if we really missed each other that much, we wouldn't be having Zoom happy hours. We'd be having VR happy hours, but we weren't. And you have to ask yourself, why is that? Why is everybody buying a PlayStation when an Oculus Quest is actually cheaper and it's supposed to be a much better experience? And the answer is that it's not. And the answer is that it's not broadly designed. Those experiences are not designed for a broad variety of users. You can teach your grandma how to get on Zoom. You are probably not going to be able to get your grandma in a VR headset. And the reason why is because it's uncomfortable for a lot of people. What I'm going to talk about here shortly is how we did a usability analysis for a whole bunch of VR headsets to help the Air Force decide on which one they were trying to use for one of their solutions. And talk to you about all the different issues and things you have to consider. But I think that's one of the reasons that we really haven't seen VR pick up like it was supposed to. It is very important for y'all to understand what usability is also not, and this picture should give you a guess. It is not rocket science. It is not actually science. It's not research. There are a lot of people who like to talk about like citing research and best practices on learning science and things like that. Usability is not that. The people who conduct usability analyses are generally considered to be human factors engineers. And the reason that the engineer title is in their job and not the scientist is that when we're talking about science, we're really talking about principles that can be broadly applied across the industry. And we're talking about things like how your memory works, and that's universal to people. When we're talking about a usability analysis, we're talking about something very specific to a particular solution. So it's not part of understanding how people work. It's a part of understanding how a particular solution works, specifically with regard to the human-computer interface aspects of it. So it's not science. If you hear people say that like usability is science, like it's not. There is math involved. There are numbers involved, and that's usually a prerequisite for research. But we're not furthering the industry here. So you can't take the results of one usability analysis and apply it to a different solution. Like you have to do this every time. Also, you need to do this sort of thing iteratively, because the faster you can spot problems with your user experience, the faster you can correct them. And it's going to be a lot less costly if you can catch them early versus like way down in the process. So that's kind of a broad introduction to it. So I'm going to talk to you a little bit, without getting into too much proprietary information, about this system that we did a pretty extensive and thorough usability analysis of. And we did this for our Air Force clients. I'm not gonna be able to talk too much about the proprietary aspects of this. I can't tell you too much about who's doing this work, because we did it for another company, as you can imagine. And also because it's government secrets, if I told you, I'd have to kill you. So we're not going to do that. But what I'm going to tell you right up front is that this is probably way overkill. And it's an example of how complicated this could possibly be, but it also gives you an example of all of the things that you might want to consider. The way that we do these analyses is at the very front end of it. We have to understand what the end user is trying to do. We have to understand what the learning objectives are. And we have to understand really how the technology interfaces with them. So there's a lot of upfront work that you have to do to establish what the learner's expectations are. I can kill you over Zoom. You have no idea who you're dealing with. Anyway, so this is not just the VR headset. This is an entire system, right? So there are some things that we've had to do that you probably will not ever have to do. But basically, the Air Force is rethinking the way that they train pilots. And if you think about pilot training right now, it's a huge simulator that you sit in, and it looks like the inside of an airplane, and that's not going away. But there are some things that pilots can learn in a much less expensive way. And this is much less expensive than a full-on airplane simulator. And that's why they're doing this. They're trying to save some money and provide an engaging and realistic experience at the same time. So their idea is that if they use a VR implemented headset along with this other getup, which simulates the major aspects of a cockpit from a field perspective, then they can get that same experience without having to pay millions of dollars for a simulator. So that's basically what we're doing. Just to give you a quick intro to what the system is, you see the VR headset there, right here, this is primarily what we were doing an evaluation of, is helping them choose the headset, because with a system like this, a variety of them work. So we looked at a bunch of them. You can see the other aspects that are simulations of the inside of a cockpit. So you've got the seat. Obviously, we had to evaluate the seat, make sure that the seat felt right, and worked in that way accordingly. You've got the stick and the throttle, and even the pedals that are inside of an airplane were simulated here. This is an example of what we call in the defense industry embedded training also. So, and it's really important when you think about VR and the kinds of tasks that you train in VR, if it requires sensory input that's not just your eyes and your ears. If I'm trying to train you to do a task that involves your hands, usually in our industry, we work a lot with trainers that look like this, because there's a concept. It's not like an official concept. It's not, but it's a word that we throw around called negative training, which means negative training means I'm actually teaching you to do something wrong because my simulator is not high enough fidelity. And that's what we're trying to avoid here. It has to be just good enough to simulate the task that we're trying to train without being overkill and overexpensive. And there's a sweet spot there in the middle. So anyways, you can also see that there is a monitor and a keyboard here that helps set up the scenario. The learner doesn't actually engage with the monitor and the keyboard. The instructor sets everything up for them there. So another important aspect is you have to consider all of the users of your technology too. So not just the learner, but also the instructor. And we had to make sure that the instructor could do what the instructor needed to do in this situation too. All of this is attached to a learning management system, and we had to determine the extent to which it integrated well with the learning management system. So as you can see, there's a lot that went into this. These are the headsets that we evaluated. These are obviously not the latest and greatest headsets. We did this work a couple of years ago at this point. We continue to do this work. We've moved on to helicopter simulators at this point, but we are continuing to evaluate new headsets for them all the time. There are some technical issues that obviously you have to consider when you're dealing with a big integrated system like this, and especially because the data we're moving to a learning management system, what we had to do is make sure that they were interoperable, and that's something that I'll get to in a little bit. So the data has to flow in a way that's easy for people to access. The level of visual fidelity is important here. The price point was important here. But these were the 6 that the Air Force had picked out as the contenders that they wanted us to evaluate. So what I'm going to talk to you about are what we call the 5 F's of usability. And I like this because some of my favorite words start with F, and it's easy for me to think about. So you can keep these in mind. This is not entirely new concepts. The 5th F is, but the rest of these are commonly used when we're talking about usability. And what you'll end up doing if you do this is these are the things that you have to understand about how your technology works and how a person would interact with your technology. And then you basically have to design measures around that. There are some standard measures that I'll speak to here in a minute, but usually you have to come up with your own measures of this. So first of all, we're going to talk about fit. When we talk about fit, we're talking about, in this case, ergonomics. So making sure that your body fits in the design of the hardware or the software in such a way that it facilitates use. In this case, it was important because we're using a VR headset. So one of the barriers to entry for VR for a lot of people that I know is that they're worried that they're going to get sick. There's a lot of simulator sickness that does happen, honestly. And for some reason, my Oculus Quest makes me barfy and the first one didn't. And I don't know why. But what we're trying to do when we talk about fit is understand the extent to which something is comfortable. And all of these are important because if you're not comfortable with something and you don't like interacting with it, you're not going to do it. And we're trying to get people to adopt these systems. And if they are uncomfortable or unpleasant, or they don't do what you think they're supposed to do, then you're just not going to ever use it. And we're trying to avoid that scenario. So that's one of the things that we're trying to get at here. So fit speaks to that. Does this thing stress you out? Does it make you uncomfortable? And if it does, then you're probably not going to learn anything, right? So what we did was develop measures of this. So we went through and figured out what are all the tasks that somebody is going to have to accomplish in this system. And when they accomplish all of these tasks, meet all these learning objectives, is it comfortable for them when they do that? That has to do, in this case, a lot of the relative position of the different components of the system. In the headset in particular, what we were focusing on is this thing is it hard to get on? Is it hard to get off your face? If it's not comfortable on your head, then we have a problem. Can I sit down in this thing easily, or is it like a Walt Disney World ride where it takes me 37 hours to get out of the thing because I've got seatbelts everywhere and I can't even get up after the ride? It kind of like your car seats. Do I have to like sit way back, or can I sit forward and can I adjust it? Where is everything? And also with the headset in particular, is it able to be aligned in such a way to reduce the causes of simulator sickness? The main cause of simulator sickness is really a mismatch between your eyes and your ears. And your eyes are telling you something that your ears don't jive with. So that's one of the things that we had to consider is whether or not you can adjust your interpupillary distance. When you're looking at a solution like augmented reality, when you've got a headset, whether or not your users are wearing glasses is actually really important, because in some cases they don't accommodate for glasses. And a huge population of your learners probably wear glasses, and you have to think about that. I have seen that there is forthcoming glass for all of these systems. I'd say probably 5 years. It'll be commercially available. That will accommodate your prescription also. So that is coming down the road. But until we are there, you have to think about that. So these are all things that we had to understand first. And then we developed a questionnaire. It's basically a Likert questionnaire, like 1 to 7. Like, how would you rate this system in terms of all of this stuff? Your second F is your feel. So this has to do with your psychological reactions to the system to make sure that it, based for lack of a better word, that it feels good. Is this something that supports an environment in which you feel comfortable learning? And by that here, what we're talking about is if I have to see something close and something far, can I easily change my point of view in here? In this system, there's a lot of auditory feedback and a lot of haptic feedback from the hardware. And so does it make a lot of racket? Is the noise level okay? We did some measures of immersion to see, do they feel like they're present in the environment? If I move the throttle, does it move in the way that I expect it to? And then we ask them about their self-efficacy. And this is actually an important thing to think about, is the extent to which people are confident that they can do the things that they need to do in the system. So again, these are questionnaires that we developed for this. There are quite a few templates that you can use, and I'll direct you to those here in a second. But all of these are things you have to really understand and do a task analysis really of all of the things you're trying to get at, and make sure that you measure all of the aspects of it, because it is actually pretty important. And keep in mind, if any one of these things is not at least acceptable to your learners, they're going to be like, I don't want this. And then they're not going to use it. They're going to go back up the chain. And then whoever's in charge of this is going to say, you know what? No one's using this. Why am I paying so much money for it? VR broadly sucks. We're never investing in this ever again. And I think another reason that VR tech hasn't really picked up is that people have a bad experience once and then they won't ever go back. Okay, your third F is your form. So this has to do with what some people will call physical fidelity. When we talk about fidelity, there's like a million different varieties of fidelity, and that's like a whole different discussion. But when we talk about physical fidelity, this is the extent to which your experience in the solution matches the real world enough for you to be able to buy it. So one of the arguments that we've had for decades is the extent to which something has to be realistic. And really, it doesn't have to be that realistic for you to learn most tasks. But sometimes it does. And when you're flying a plane, sometimes it definitely does. When you're learning a variety of other things, it doesn't have to be super realistic. And that's one of the reasons that people are engaging in VR now, is that despite some of the graphic limitations of it, like, you can still get by just fine. And especially with like lower cost solutions. So it's not the extent to which it is high fidelity, it's the extent to which it is enough in terms of fidelity. So in this case, one of the most important aspects was field of view and your ability to see in the periphery. If you're a pilot, you always have to kind of look around, especially when you're trying to land an airplane or take off. You need to have a good field of view. Interestingly, having a very broad field of view contributes to nausea in a virtual environment, because the resolution out here on the ends is usually not very good. There are some solutions that are coming out. The Vario headset that should probably be available in a couple of years commercially is extraordinarily good in terms of field of view. But it has to do with, in this case, the cockpit of the airplane has a lot of dials and bells and whistles and stuff in there. And if they don't look right, then you're not going to learn the thing that you're going to learn. So in this case, there were some elements that really had to be modeled well, and some of them that did not. So if the pilot looks out the window, they don't have to see like the exact right number of cows that live in the field next door to the airport. Like, that doesn't matter, but the inside of the aircraft definitely does. So that's the sort of thing that we evaluated here. Mostly the buttons, the knobology, all of the levers and the different aspects of it. Like, is it enough to where you can learn this task without it being either distracting or promote what we call, again, negative training? Your fourth F is function. This has to do with two concepts, which are reliability and validity. And some of you are probably more familiar with the concepts of reliability and validity than some of these other ones. And this has to deal with user expectations. But reliability, it basically means repeatability, and the extent to which every single time I do this, it's going to do the same thing. If you have a reliable best friend, then every single time you go to your best friend with your problems, they're going to give you advice and it's going to be good, and you know that you can cry on their shoulder. If somebody is not reliable, they don't show up when they're supposed to show up for you, and that's how you lose your job. So that's reliability. And validity is the extent to which it replicates the real world in a way that is realistic. So in this case, this has to do with user expectations. And your user expectations are really important because, and when we talk about usability, we talk about the extent to something meets expectations. When you open a mobile app for the first time, you probably don't need an instruction manual on how to use that app, because there are design standards that are in place. And a lot of our work in this area addresses the extent to which something meets design standards. So the question, when you open a mobile app, like, you know what those little three dots mean. That means there's a menu there. You know what that little box with the arrow means. That's a share sheet. Like, you have standard patterns that you can come to understand what they are. And if the patterns are consistent throughout the whole system, then you can learn that pattern once and then you can apply it across the board. But one of the problems that we had with this particular solution, because there were multiple companies working on it, this little button did one thing on one part of the solution, and the same button did something else on the other part of the solution. And that is really confusing. It's not reliable, and it's not consistent. And that's the problem with it, is that if those interactions aren't consistent, then you're going to have a bad time. And that was one of the big issues that we found with this. And so we had to go through and make sure that from a design perspective, things were designed in a consistent way. And this has to do with your visual feedback. It has to do with the sounds that it makes, like, all sorts of different aspects of it. So you really have to look at it from a multisensory perspective too. Finally, future use. And this gets a little bit to the extent to which people like it enough to where they could see potentially the value of it. Before a system is implemented, it's really hard to determine the extent to which it's going to be effective for learning, but you can ask people if they're like, yeah, I could see how this would possibly work. And this will help you get to buy-in. And this is something that we do that most people don't actually do, but it really speaks to the extent to which people can see the value of this. And they're like, yes, in the future, I would go to this system for this sort of a problem. And we ask questions like, would you choose to use this if you had a choice? With pilots, the answer is usually no, because they want to be in an airplane at all times, because flying an airplane is fun, sitting in a simulator is not so much. So that is actually a challenge, and one of the reasons that we included it for this particular use case, because with that particular audience, there are acceptability issues in terms of whether or not they would actually want to use this. So it has to be at a certain level. This kind of gets to your level 1 training effectiveness analysis, if you think about it that way too. But the most important part of all of this is getting recommendations from your users on how to fix things that are broken. Usability is something that shouldn't just be evaluated at the end of the day. We start with usability at the very beginning from the design process. As soon as the interfaces are designed, we run them through users and say, okay, if this were a button, what would you think that it would do? And if this were a switch, what would you imagine that it would do? And that's how you assess your learner expectations. So that's broadly the 5F framework for how to do usability. So the question is, how do you actually do this? There are a variety of scales. So there's kind of 2 approaches to doing a usability analysis. All of this stuff, if you go to usability.gov, this is a fantastic site and will get you access to pretty much anything in the world that you would need to understand this more in depth. This is the sort of thing that is critically important, but it's also usually an afterthought. So before you start looking at hardware and software across the board, these are things to think about. Because it's not science, there's not like a super rigorous there's not like a socially acceptable way of doing this that everybody does it the same way. There are scales that people usually use, and they have been validated. The systems usability scale is one. There are some specific to mobile learning. There are not really any specific to simulators right now or VR, but what you can do is take any of these questionnaires that exist and tweak them and make them your own. Like any assessment, it's important that you have a variety of questions. It's important that we usually use Likert scales for them. Make sure that you can collect free text in these, because the most valuable part is getting their feedback on, if it doesn't do what it's supposed to do, then what would you want it to do instead? And just because it works for you doesn't mean it works for them. And you really have to listen to what they have to say. And even the best UX designers in the world that I have ever met often design crap. And it's not because it's inherently bad. It's because it doesn't meet the user's needs. Just remember, it's not your remote, it's your grandma's remote, and you are very different people. So you really have to understand that. Also, these other 2 sites have really good overviews, but that's basically the best advice I can give you on where to get information on this. Like I said, we developed all these questionnaires ourselves. I can't really share them because they're proprietary to the company that we're working for, but this will tell you where to go get them. All right, so we've got a little time left. I imagine there are some questions. I'm going to jump into the Q&A. And I don't see any, actually. So do any of you guys have questions for me? So it doesn't look like it. My contact info is available. I will share these slides on the site here, so you can pull them down whenever you want. feel free to look at these resources. And as always, you've got my contact info on the very beginning of the presentation here. I will pull it back up. And feel free to reach out whenever you need anything. All right. Thanks, everyone.